Hello, you all. This is Mr. Griffith, and today we are talking about how to solve quadratic equations by factoring. Um, just got to be honest with you, I'm probably gonna mess up, but at some point, so just bear with me. But here we go. The zero product property is going to be the most important thing that we can use in terms of solving by factoring. Now, so far you have seen quadratic equations in a bunch of different ways, and it may have been a while since you have factored, but this is what factored form of a quadratic looks like. Something times another something. You have parentheses and parentheses multiplied together. They're pushed up together against each other. That's multiplication. The zero product property. If I were to tell you, you don't know these two numbers, you only know uh, that if you were to multiply these two numbers, you get the answer 0. So you don't know what these two numbers are. Any number times any number, but you know that if I tell you they multiply together, they're equal to 0. That means that one of these two numbers, even though you don't know them, one of them is 0. That's the only way that it's possible. One of them is 0. It could be 0 times 1, 0 times 2, 0 times 3. It doesn't matter what the other number is. As long as one of these is 0, you're good. 3 times 0, 4 times 0, 5 times 0, it doesn't matter. As long as one of these is 0, it could be both, I guess, then your answer is 0. And that goes the same for factored form. You have these crazy things written inside here times another crazy thing written inside here. But in the end, this is a number and this is a number. And as long as one of these two things is 0, then this will work. Like 0 times a million is 0, right? Or 0 times x minus 2 is 0, because 0 times anything is 0. So we're going to use that to help us solve equations in factored form. So our first one, 2x minus 1 times x plus 3 equals 0. I am going to set 2x minus 1 equal to 0, because that might be the one that equals 0, or it could be the x plus 3. I don't know, and so I'm going to find out both possibilities. There are multiple possibilities. When you are solving these equations, solve it the same way that you've always solved equations. So for my class, we think about, okay, what do I need to do to move to get x by itself on this side of the equation? First, I will add 1 on both sides. 2x is equal to positive 1. From there, I need to, this is 2 times x equals 1. I need to divide by 2. And I'm left with x is equal to 1/2. X is equal to positive 1/2. There's my first answer. So we just got to think about how we can get x by itself on each side of the equation. I subtract 3 on both sides of this equation to remove this plus 3. And x is equal to 0 minus 3 is negative 3. There's my other answer. So I have two answers. X could be 1/2 or x could be negative 3. And if you think about this, I want you to imagine for a second you took this negative 3 and you put it back in for x. It doesn't really matter. 2 times negative 3. You could do all the math on this side. Sure, have fun with that. But if I were to plug negative 3 into this parentheses, negative 3 plus 3 is 0. This whole parentheses becomes 0. It doesn't matter what number is on this side. Some crazy number times 0, yeah, that equals 0. This works. And I guarantee the same thing will happen here. 2 times 1/2 is 1. 1 minus 1 is 0. It doesn't matter what 1/2 plus 3 is, because 0 times whatever that is still 0. So that's how this property works. To make it just more simple for you, you set each parentheses equal to 0 and solve. And so that is really your only step when it's already factored for you. Both of these problems were already in factored form, which was really nice for us. We can solve our equations pretty quickly by setting each factor, each parentheses, equal to 0 and solving. And in this case, we get x equals negative 3 over 2. And in the other, we add 1 on both sides. We get 3x equals positive 1. We divide by 3 on both sides, and we get x equals 1/3. For our other answer, we have two answers. Notice this pattern though. Sometimes, yeah, you have two answers when solving quadratics, and when you've been solving quadratics, you've seen how you could have two, one, or zero answers, and that's going to be no matter what way of solving quadratics we look at. That will always be the case. You could have two answers, you could have one answer, or you could have none. So let's think about if it's not in factored form, what do we need to do? Well, there are some important steps, and you can see that I've already written that question here. What are the steps to solving quadratic equations by factoring? And I have this listed. It's a really good idea for you to take these notes for you to remember. The first thing that's really important is it has to say equals 0. Look at problem B. It says equals 64. So we're going to have to do something when we get to that problem. But for now, it needs to say equals 0. So um, it you solve your equation for 0, or in other words, just set equation equal to 0. That's step 1. In this problem, that's already done for us, which is nice. Step 2 will be to factor, and I know some of you are already dreading that, but we will review factoring briefly. I know that other classes teach it in various ways. We'll go over that. Step 3, set each factor equal to 0. This is just basically from example 1. Steps 3 and 4 are just example 1. Set each parentheses equal to 0. Solve for x. That's what we did above. We set each factor, we set each parentheses equal to 0, and then we solved for x. That's exactly what we did here. So there's step 3, there's step 4. So factoring, I get that everyone does it in different ways. Some of you all may have factored by grouping, some of you all have done the box method, some of you all do guess and check. Whatever way that you do works for you, do it that way. But if you have not found a way that works for you yet, I suggest you either reach out to your teacher, or you can reach out to me, um, or watch this video, and maybe this will be the way that makes sense to you, whatever it may be. So we've got x squared plus 16x plus 64, and the way that I teach my kids is to use the box method for factoring, because we also use this method for multiplying. We got to work our way from the inside out. Unfortunately, I only have 3 things here. I can't fit all of that into my box, so I have to do something called splitting the middle term to fill in 4 things. I'm going to turn this from 3 to 4, then I can fill this in, then I can factor, and we're good to go from there. To split the middle term, we solve a little puzzle. You may have practiced these puzzles plenty. Your first number times your last goes up top. 1 times 64 goes up top. Your middle number goes on the bottom. And the question I'm asking is, what number multiplies to give you 64 and adds to give you 16? So you gotta be thinking, what multiplies to give you 64 and adds to give you 16? In this case, that's going to be positive 8 and positive 8. And that's how this problem changes from a 16x to an 8x plus 8x. Y plus, because they're both positive. So filling in this box, we have x squared plus 8x plus 8x plus 64. And as you can see, now we have 4 things. We're good to go. We're good to factor from here. If I were to factor this way, I'm looking for a greatest common factor of every column and every row. Of my first column, the thing that they share in common, they both have an x. In my second column, they don't share an x, but they both can be divided by 8. That's what they share in common. They can both be divided by 8. My top row, they could both be divided by x. My bottom row, they could both be divided by 8. Now, it's really important that you listen to me here. It doesn't matter if you realize, oh, hey, that's x plus 8 times x plus 8 equals 0. Or if you're a little bit more advanced and you realize that this is essentially x plus 8 squared equals 0. You will get the correct final answer either way. This is more correct. This is more simple. This will save you more steps. But let's say you didn't realize that. I promise, as you'll see, you will get the same answer as everyone else. So remember, you set each factor equal to 0, and you solve. So I'm setting x plus 8 That's what's in parentheses, equal to 0, x plus 8 equals 0, and I'm solving, and I get x is equal to -8, and I get x equals -8 again. Well, so my answer repeated. There's no reason to be redundant, guys. Don't repeat yourself. X equals -8, and remember I said earlier, you could have two answers, you could have one answer, you could have none if things go terribly wrong um, for you. But this is the case of you having one answer, and that should make sense over here. There's only one factor here. I set x plus 8 equal to 0. I solve. So even whether I solved it over here like this and realized that just repeated, or I solve it over here, I'm still getting x equals -8 as my answer. And that's fine. Just to have one answer. That means this is the only thing that if you were to put it in for x would make this whole side become 0. If we look at b is not set equal to 0, and it is not hard for us to fix that. I just need to move this 64 from the right side to the left so that it could say equals 0. And the only way I can move a positive 64 from one side of an equal sign to the other is to subtract it. This becomes x squared minus 12x minus 64 equals 0. And from here it becomes the same process of factoring. I need to set up my puzzle. First number, 1 times my last, goes up top. My middle number, -12, goes on the bottom. And I need to solve this equation. You should pause the video whenever I do these and see if you can figure it out yourself. So right now you should pause the video and see if you could figure out what multiplies to give you 64 and adds to give you -12. What multiplies to give you -64 and adds to give you -12. And the answer is -16 and +4. So when we set up our box, this is x squared minus 16x plus 4x and then minus 64. So you can see how the first part and the last term do not change, x squared and minus 64. It's just the middle term that's being split because of this puzzle that we just solved, minus 16x plus 4x. You don't have to show all this work, but it helps you to see what it is you're doing, where these numbers are coming from. Remember, you're looking to see what they share in common of each row, or each column and each row. My first column, they share an x. My second column, a -16. They can both be divided by -16. My top row, just an x. My bottom, +4. And this becomes x minus 16 times x plus 4 equals 0. Set each factor. That's an arrow, by the way. I'm sorry, my handwriting is terrible. Set each factor equal to 0 and solve each for x. So those are your steps. You make sure that your original equation that you're starting with equals 0, like we had to here, and then you factor. After you factor, you're pretty much home free from there. That's where you should feel like, oh sweet, I'm pretty much done. Once it's here, once it's factored, you should feel really close to finishing. You set each parentheses equal to 0, each factor equal to 0, and you solve. Now we're going to look at how do we graph, right? And when you're graphing, so far you will have seen, there's different characteristics of the graph. You might have a y-intercept. You might have the vertex and the zeros. Those are the different characteristics that are incredibly important when you're trying to graph. And when you've seen forms so far, parts of this are easy. Like you've seen, and we changed the equation. So go ahead and take the time, pause the video, rewrite this new equation. This one's just going to be easier for us to graph. Notice that I've already created this. I drew my axes. I labeled them. I'm going up by 2's on the y, by 1's on the x. You should also do the same, right? It's going to be important for this, especially as you can see real quick that our y-intercept is a -8. that would have gone off the graph if these were going only up by ones. You'd be down here, which would be really annoying. So that's why I'm going up by twos to fix this problem. But so my y-intercept is this last number. The vertex, as you've seen in a previous lesson, is a little bit more involved to get. But the vertex, h comma k, is first you find h, then you solve for k. This is done in a previous video, so if you need help, you should look at that. I'm going to do it very quickly as a mini review for you, but also knowing that you've already seen this. So if you're still confused by what I'm doing, please go back and look at that video. H is negative b divided by 2 times a, and in this case, my b is a negative 2. Notice how it's negative 2 now. Divided by 2 times a, my a value is a 1. Simplifying, negative 2 is positive 2. 2 times 1 is 2. This whole thing simplifies to 1. So my h is a 1. Of my vertex, my x coordinate is a 1. To solve for k, I'm going to plug that x coordinate, that 1, into this equation. So 1 squared minus 2 times 1. I'm just putting a 1 in for x. Minus 8. 1 squared is 1. Minus 2 times 1 is 2. Minus 8. Which is 1 minus 2 is negative 1. Negative 1 minus 8 is negative 9. So my vertex, my h comma k, is 1 comma negative 9. And again, if that was too fast for you, please look at that other video where it goes much more slowly and more in depth on solving for that vertex. But 1 comma negative 9 is my vertex. 1 comma negative 9 is right here. Negative 9 is between negative 8 and negative 10. So we have our y-intercept, we have the vertex, the turning point. So it should look something like this, right? Where it turns around here. Now, what we need is our zeros. Where does it cross the x-axis? Somewhere like here and here, right? Not really sure yet. The way that we find this, as we've already talked about, is first we factor this, and then we set each factor equal to 0 and solve. So that's exactly what we're going to do. I'm setting this function equal to 0 to solve for that's why they're called zeros. Setting this equal to 0. And now we need to factor. We set up our puzzle. First number times our last goes up top. Your middle number on the bottom. Solving this puzzle, what multiplies to give you negative 8 adds to give you negative 2. Pause the video to try to figure that out. The answer is going to be negative 4 and positive 2. Negative 4 times 2 is negative 8. Negative 4 times 2, or negative 4 plus 2 is negative 2. So that's how this splits. This becomes a minus 4x plus 2x. So from here, we're almost home free. We've got a factor using our box method. But hopefully this is getting more and more simple for you. If it's not, it is really, really important that you take the time to learn how to factor. Factoring is not going to go away, unfortunately, for you if you're struggling. And if you're doing well, then I guess that's fortunate for you. But you should really take the time to learn how to factor because it will not go away. You will be factoring all throughout Algebra 1 for the rest of the semester and in Algebra 2. Where did I get the x and the minus 4? This is what this row shared in common, what this column shared in common. My top row can both be divided by x. My bottom row can both be divided by 2. So that's where we're at. I set x minus 4, x plus 2 as my factors. These are equal to 0. I set each one individually equal to 0. I solve each equation for x. And we have our zeros. x equals 4, x equals -2. These are my zeros. These are my x-intercepts. These are where it crosses the x-axis at x equals 4 and x equals -2. Now I'm going to change the color of this so that it doesn't bleed through, but this is what you're looking at. We have a turning point here, right? It goes through here, it goes through these points, and this is what it looks like roughly, obviously, very rough. So there you go. That's how you graph, and to just make it more simple, you just need some key characteristics. You need a y-intercept, you need vertex, you need your zeros to graph your quadratic effectively, and more accurately than just if you just knew your vertex, you'd be guessing in the dark with what this should look like. So there you have it. Your homework is varied by your teacher, but if your homework is out of the textbook, you're looking to do problems 20 and 21. That's just like example 1. 24 and 25, exactly like example 2, and problem 34, which is very similar but working backwards from the example we just did. So you should be thinking about, okay, here's 1 0, here's the other. What might that look like if I were to have this? So try working backwards. You know your zeros, so see if you can go back to the factored form. There's your homework. Oh, and 32, my bad. So this is graphing. This is the challenge problem for you to see if you can work backwards. And let us know if you have any questions. So I will leave you with this. In Desmos, this is your factored form. And you can watch how as I change 1 0, if this 0 is -2, oops, that's not changing, that's still a -2 right there. It's the other 0 that is going up and down. If I want to leave this one at, well, apparently 1.92 and -2, notice how that's changing. The one we just had was, one of our zeros was a 4. Wow, I'm really bad at that. The other was -2. And this looks just like the graph we just drew. A vertex at 1, -9, y-intercept at -8, a 0 at +4, and a 0 at -2. So this is that graph that we just drew up here on example 4. Obviously, mine's a little bit rougher than theirs, but that happens. So again, let us know if you have any questions, and take care.